oh, maybe a proposer doesn't sign off on a block by itself, but a proposer's key is split into like a DVT type scenario, and there is a committee of like
Mm,
50 people who have staked much, much more. And they actually have to sign off on this transaction. And if they sign off on a wrong transaction, they're going to get slashed, not 32 ETH, but now 1 million. We have all the pieces kind of in the space floating around. We have DVT floating around. We have economic security with EigenLayer floating around. It's going to be a whole bunch of fun work to make this all work, but it's possible to make it work at much higher economic fidelity than 32 ETH because that is needed to build $1 billion decentralized stable or $100 billion decentralized stable.
Hey everyone, this episode is brought to you by Kinto, the safety first L2, which is accelerating the transition to the on chain financial system. They've got some very cool features like user owned KYC and native account abstraction, which solves a bunch of the onboarding and bottleneck problems that many L2s suffer from. So you're going to be hearing all about them later in the program. But if you want to learn more and better, if you want to join their launch program, Engen, ENGEN, you can click the link at the bottom of this episode. Go check them out. Tell them I sent you.
All right, everyone. Welcome back to another episode of Bell Curve. Before we jump in, quick disclaimer. The views expressed by my co-host today are their personal views, and they do not represent the views of any organization with which the co-hosts are associated with. Nothing in the episode is construed or relied upon as financial, technical, tax, legal, or other advice. You know the deal. Now, let's jump into the episode.
All right, everyone. Welcome to the first interview-based episode of this season of Bell Curve on Restaking. I'm joined by my trusty co-host, Miles O'Neill of Reverie, and of course, Sreeram Kannan of EigenLayer. No one that would be rather starting the season with Sreeram, so thank you very much for joining us.
Thank you so much, Mike. Miles, really excited to be here.
Yeah, we're pumped. Now, a little disclaimer, this episode is going to assume a certain amount of knowledge about EigenLayer, the protocol, and restaking generally, just because we have so much that we want to cover with Sreeram. And for folks who don't have this history, I would highly recommend. The three of us did an episode about a year ago on Bell Curve, the intersection of liquid staking and restaking. We'll link that in the show notes where Sreeram does a magnificent explanation of what restaking is. So I would highly recommend you go back and listen to that. But Sreeram, I want to jump in and get a little bit of a state of the union, so to speak, on the ecosystem of restaking. And if we rewind the clock a year, I feel like so much has happened since the three of us last talked publicly on this podcast. So since then, we've seen over 15 billion and counting in deposits flow into EigenLayer. EigenLayer has obviously launched its mainnet and token. We've also got a much more diverse ecosystem of AVSs. The current estimates between 30 and 50, something like that, which is super impressive. We've got liquid restaking, which was just becoming an idea the last time the three of us talked, but now there are many LRTs that exist. And on the horizon, there are a couple of competing platforms alongside EigenLayer these days. So we want to get into all of that, but maybe just starting at a really high level from your perspective. I guess knowing what you know now about this last year, what do you think has gone well in terms of restaking in the ecosystem generally in EigenLayer? And then maybe knowing what you know now, is there anything that you would change, do differently, improve on, double down on? Give us a little bit of the state of the union from your perspective.
Yeah. Um, the the adoption has far outpaced uh, our own bullish bets on where we would be in 2024 May. And I think whether it is in the quality of people building AVSs, whether it is in the emergence of liquid restaking, we were thinking this is like a minimum 3-4 years before we see anything like this. The emergence of the roll-up ecosystem being built on EigenDA, the amount of stake and interest in EigenLayer, all of these have definitely outpaced our upper confidence limit. So which means basically that if we rewind the clock, if we knew that this is where things will be, we would have definitely done things differently. That's just because we would have allocated more resources to, like, for example, engineering is lagging, adoption on our product roadmap. Like that's a big thing. And part of it was, we are conservative in allocating resources before we know there is like market fit, instead of funneling all the resources into it and then knowing like what's going to happen. So that is definitely one thing we would dial differently if I go back back a year, be much more like aggressive in growing our engineering and shipping even faster and more aggressively. The public communications is the second one, which I think we would have done differently. Is, for example, we went from like a nobody knows who they are startup to like something pretty central so fast that we hadn't internalized it. That, oh, if you make a small change now, like these LRTs have to make a change, those AVSs have to make a change, this rollup has to integrate differently. It's just a lot that is kind of downstream of this. And we had not designed our processes, both engineering or communication, to kind of match that. It's kind of like Ethereum has this all core devs call, and like we need to get everybody on the same page. Seems like we need to move to a model like that. So that's not something that was on the horizon. Like now people think it's obvious. Like 4 months back, it's not obvious that we'd be anywhere near here. So it's a very fast rate of change. So we are adapting as an organization to all these like emergent changes. In terms of just market structure, I think certain things we got right. And I think the first thing we got right is we said EigenLayer is an objective platform. We are not building an LRT. Everybody thought this year, last time, that EigenLayer is going to do their own LRT or like something and compete with Lido and this and that. And we had stated that we wouldn't do it, but like, people had to wait and see it to believe it. So because it came from a kind of like a foundational view that protocols which make objective judgments let a lot of other like subjective judgments flourish on top of it. And so that's the view that we took. I think that view proved more right than we would have imagined. There is an alternative universe that would be like we have this and nobody builds an LRT or anything on top, and maybe it is a fact that like without an LRT on top of EigenLayer, this ecosystem doesn't work. And it could be a possible worldview. And so that's something I think we did right in terms of market structure. In general, that's been like our principle of building EigenLayer is build the minimal coordination systems that let other people build everything else. Like anything that's deadlocked by coordination, we try to build. And anything that's not deadlocked by coordination, we try to externalize. Some people think we should, or even in our own companies, people think we should be like, oh, maybe we wouldn't have built DA if we knew that we would have like 40 AVSs at this time. There's some truth to it, but there's also some misunderstanding to it. And I think this is not well understood, that you cannot really have a system of crypto economic security without a powerful, scalable DA nearby it. It's because crypto economic security comes from slashing and slashability. To do the slashing, the inputs required to trigger slashing should be publicly available. One could take a narrow view of cryptoeconomic security and say, oh, only things that's published on Ethereum you can slash for. But that makes the use cases so narrow that it's not, broad enough. So, a system of cryptoeconomic security without an adjoining system of data availability is actually like a big hole. And I think we did the right thing by building DA along with EigenLayer and having this very ambitious scaling roadmap for EigenDA, which we continue to execute on.
Makes a lot of sense. And I'm curious, what has been the most challenging engineering problem? And it feels like your decision to support native stake maybe represents like 90% of the work, right? Because we've already seen a few new like emerging competitors come out with only supporting liquid assets, and feels like it's pretty easy to spin up. And so, going back in time, like, is that a decision that you're proud of and you see as like a core differentiator that's going to be hard to replicate? And maybe just speak to a little bit of the challenge. I know I kind of answered that for
Yeah,
you, but
no,
And,
that's
and
a
also
great question.
for the
Yeah.
for the audience, Sreeram, if you could also just define native stake and what that is.
Yes.
Yeah.
Yes.
Yeah.
So there are two ways to participate in the EigenLayer protocol, and one is using, you can deposit an LST, or in general any ERC20 token. The second way, which we particularly made for Ethereum, is the ability to do native restaking, which is you stake in Ethereum. Normally, when you stake in Ethereum, you set your withdrawal credentials to your hardware wallet wherever you want to withdraw the money later. But instead, when you stake through EigenLayer, you just add a step in your withdrawal flow that the withdrawal goes from Ethereum to the EigenLayer contract back to your hardware wallet. It's kind of like a step. And so that's called native restaking. And it is true that native restaking is much more complex than the other part of actually just building an LST restaking. The reason we did it is the reason we do a lot of things in EigenLayer is kind of complying to the Ethereum ethos. And one of the big things we want to support is the ability for all stakers who may or may not trust a particular like LST or a third party to participate in the restaking economy. This is kind of like a flashbox type view of everybody should be participating as an equal in this economy. And if you don't have native restaking, it basically breaks that paradigm. It basically says, oh, I can do STETH or RETH, but I can't be a home staker. I can't be an institutional staker. I can't be Coinbase and like participate in EigenLayer. I think this entrenches certain players relative to other players, and it was super important for us to do this. What we did not know is most of the native restaking was going to happen via native liquid restaking. This is not a thing we know. And I don't think this is the natural consequence in like a 5 to 10 year time period. Because as institutions come, as we get more home stakers, we don't know which side the fork may go, but whichever side the fork goes, we are ready for it. And I think that is a very important thing. This is particularly important for things like proposer commitments, where you're trying to do something on top of Ethereum L1, right? Like I'm an Ethereum L1 and I modulate like what I'm doing on top of it. I think for those things, this matters a lot, because otherwise, if we are able to do proposer commitments are very, very powerful. You can start doing lots and lots of different commitments. And if only Lido can do it, then relatively, so the whole architecture of how Ethereum designed for MEV neutrality across all the different players just gets broken. So so I think of anything that has native restaking is decentralized restaking, and anything that entrenches only a certain kind of LST or a couple of LSTs is centralized restaking. So that's one way of thinking about it.
Makes a lot of sense. It's like looking at the future and saying this is going to become, a larger and larger percentage of the overall stake is going to participate in restaking. If there is, a barrier to anybody outside of those using something like stETH, right, or another LST, it just further moves the incentives to stake with them, right? And that's not a healthy outcome for Ethereum. I think we can all agree on that. So it makes a lot of sense. The challenge, of course, is that the state of the beacon chain is very different than or hard to communicate with the execution layer where the contracts live, right? And so these proofs being sent back and forth is really kind of like a new engineering problem that I think will continue to be refined.
Yeah,
as you guys
that's
talk
right.
about.
And one of the views we took there is also a little bit more hardcore than what most LSTs. LSTs have the same problem as moving this information. We said either we have to have a ZK proof or use enshrined beacon state and make proofs relative to that, rather than using an oracle, which like Lido and Rocket Pool were using for some time. So these decisions definitely made our life more complicated. And there were like when you make these complex protocols, you take a step and you realize it's a misstep, and then you have to turn around and then do something else. And then like
Right.
Ethereum has like a EIP, which now brings the beacon state directly. Now you have to do proofs against that rather than so it's a whole thing. So I agree with Miles that it did take up a lot more effort than if we didn't do it like that, for
Yeah,
sure.
it's a moving target and it's a difficult accounting problem as well. But yeah, I think you guys have identified that and it's kind of one of those non-obvious things that's happening under the hood that, unless you're an operator, you probably don't feel that pain day to day, but it's super important, right? So yeah, really appreciate that. And maybe just to move on like a little bit, I've been, so we talked about the State of the Union. EigenLayer has this first mover advantage that's pretty significant in terms of TVL on the supply side and number of projects building on the AVS side. And kind of think about, okay, how large is this first mover advantage? And I think that it really comes down to two questions. How significant are the economies of scale on the supply side, right? Is it a dynamic where the more TVL you have, the cheaper the security you can offer, right, to the demand side of AVS is? And the second one I wanted to ask you about, which I think is arguably more important, is are there network effects to restaking protocols, and specifically demand side network effects, meaning the marginal AVS that joins the system makes the system even better, right? And yeah, would love to just hear how you think about that, and then if there are, how do you position EigenLayer to really unlock these network effects?
Yeah.
Maybe being slightly opinionated about what you build.
Yeah. The term AVS is actively validated services. So any service that wants to kind of consume the shared security and decentralized trust from EigenLayer. And we called it AVSs, actively validated services, rather than actively validated chains or anything else, because I think that was what was natural to pretty much everybody. The idea is, oh, you got stake, you're going to run a chain. Like that is the obvious thing to
Yeah.
do. And I think we did not think that. In fact, I would say EigenLayer is entirely a demand side protocol. It was constructed for distributed systems builders. It is not constructed to like maximize TVL. It's kind of like an accident of history that we got some amount of TVL right now. And I think you're right in that TVL is the most like temporary network effect. Compound had $20 billion TVL like 3.5 years back, and now it doesn't, and so on. And so we don't take that part for granted that, you have TVL now, they may not exist in, even the token announcement, like one of the biggest things is what happens before and after. And like, one of the nice things with what happened was basically there's no change. Like it just goes, you can't find where the token announcement happened, which is, I think, a pretty crazy outcome. But these things are not to be taken for granted. They'll change in 6 months. Like, so I don't think there is a significant network effect from TVL itself. So going to this idea of actively validated services, it comes from a certain worldview of what needs to be built. And like the starting point of this worldview is, I think, what we call in crypto modularity, right? Modularity is like different modules do different things, but it's a specific view of modularity, which is not that there are three modules, because if there are three, maybe like somebody would just build those three, or like there are only three winners, right? And you don't need a platform to just get three winners. Like it's not a stable equilibrium. The worldview is that there are going to be thousands of interesting services. And it kind of comes from modeling what happened in the cloud, right? If you look at like computing, you had the mainframe era, which is, an analogy to the big chain era. And then you have the personal computer or a personal web server. Each company, like website, runs its own web server. And that's like a app chain era. And then you have the cloud era where like you're horizontally like figuring out what the functionalities are, and each one lives in a certain like software as a service or whatever module. And then now you just kind of integrate all these different things to make a useful end user application. So EigenLayer is built for this third worldview, which is lots of services. End services are then concatenating, end applications are concatenating a bunch of these services to make useful, productive crypto applications. So it's built on this like view of the world. And so that's why AVS is actively validated services, because you don't need these to be chains. And them being chains is actually kind of slightly counterproductive, because each chain has its own ordering function, rather than it's a service that is called for by any application, and then it returns that answer. And if it doesn't return the answer correctly, it's going to kind of be slashed and so on.
Hey everyone, this episode is brought to you by Kinto, the safety first L2 with user-owned KYC and native account abstraction that is accelerating the transition to the on-chain financial system. Now, we've been talking about Larry Fink on this program and how he's been shouting the good word about tokenization to all of his buddies on Wall Street. This is happening. And the very cool part about Kinto is that they are built to accept a whole bunch of assets and a whole bunch of users from the traditional financial system, which current L2s have done an okay job, but there's a lot of room for improvement for onboarding. So it features very nice things like user-owned KYC and native account abstraction that solve some of the biggest blockers around mainstream adoption, namely security and user experience. You can become a founding member at engen.kinto.xyz. If you believe in this on-chain financial system, join Kinto's launch program and thank me later. Cheers, guys. And the link, bottom of this episode, click it now. Could we get into some of the more almost like squishy, like branding, go-to-market considerations that some of these services might be having? Because I think, as we've seen in crypto time and time again, it's very nice for some of these new projects to be able to buy into a narrative, right? And so we saw this with ETH rollups, and obviously there are many concrete advantages to being a rollup, but an enormous amount of chains that were sort of existing in their sort of like maybe they were full stack app chains or L1s that never really got product market fit. They kind of like, hey, we're a roll up now, and everyone likes roll ups, and it was part of their go to market strategy. And so I could see projects positioning themselves as an AVS, not only because of what EigenLayer allows them to do, but also it's like, hey, I'm part of this AVS club, and everyone's excited about this, and they want to learn more, and it's kind of buying into this brand and narrative. On the other side, I could also see, maybe another restaking platform taking the opposite, taking the opposite approach. And maybe there are some big projects out there that are saying, hey, I actually think whatever the construction that I have now, maybe I'm a smart contract app on Ether, maybe I'm a roll up. This AVS thing that Sreeram's talking about at EigenLayer, this sounds great, right? But I already have a brand in and of myself, and I don't really want to be in this like AVS club. I want to be my own thing, and I want the infrastructure that restaking allows for me to just be a tool that I use, something behind the hood, something like that. So how would you compare and contrast those two approaches? Like, what are you hearing from the AVSs on the ground?
Yeah, I think to the extent that this squishy narrative of, oh, I'm an AVS exists, it's not intentional from our end. Our intention is to be like the cloud. So which means no consumer application is saying, hey, I'm an AWS cloud-based app.
Plug in.
Nobody cares.
Yeah.
Nobody cares.
That's such a crypto thing. Be like AVS, let's go. Let's make that a thing. It's really funny.
It is a crazy idea that's like a differentiator or anything. But there is one thing which is concrete and real about it, and that is when there is an economy. So to build something specialized, you need specialized counterparts. So let me explain this. right? Like if I want to be a data availability layer, let's say, I need an execution layer, which is just an execution layer. You can't be a data availability layer if there is no counterpart of the specialized stack. And that's the same thing with EigenLayer, is what it's doing is creating an economy of services. And you can be one of the services because there are a lot of the other services, and just a service by itself doesn't have like an economy to stand on itself. An AVS could exist only because other AVSs exist. So this is a different kind of like this is like creation of a kind of evolutionary niche. So now that there is this family of AVSs and AVSs are supposed to be super specialized, I'm the X thing, which then like is used by other AVSs. I'll give you an example, like a proof of location service. Okay, it's a service that says, hey, I'm going to measure each of the operators where they are and give you like a certificate of location. Now, what do you do with this service? Like if you had it outside, like it's not clear what you would do with it. But inside an AVS economy, it could be like every AVS comes in and says, hey, when I give operator rewards, I give like a decentralization bonus for more decentralized operators. So it's a service that caters to other AVSs. And because the other AVSs exist in a kind of like a cooperative economy, you can be an AVS. So if I just take the narrative part out and then ask what is the kind of like, that would be something where you're thinking consciously about the remainder of the evolutionary ecosystem and then say, oh, I'm there's this big bucket to slot in or to create inside of that. And that I think is like something concrete that could happen and we see happening to an extent already.
Right.
That when you open up specialization, existence of other specializations means there is opening of other super specializations to show up. And so that's an effect where it goes beyond just simply branding. It's the same reason why every chain needs a DEX, right? Like you're a chain, you need a DEX, you need a lending platform, you need this, you need that. And the first one obviously needs like that with a higher like adoption momentum than the next one. So being the first kind of like the restaking platform and being builder centric and thinking a lot about what AVSs should be, what should be their right structure, how they will interoperate. We have a little bit of an edge in actually empowering and creating these things. So one thing I find when like talking about AVSs is EigenLayer is not only premised on a certain model of how the ecosystem will be built, but also in a certain model of decentralized trust, which is things like attributable security, things like, you should have insured economic security, right? Where you know how much security you have and you should be able to slash and redistribute that portion. These are new concepts. This was not how any blockchain was built before. Because they're new concepts and we invented, we kind of shepherd the AVSs to think about it like that. So imagine you're an AVS which is building on Uniswap and you're doing this much transaction volume on a weekly basis. Make sure to have more than that amount of attribution and economic security on EigenLayer. So that itself opens a niche because it's a new trust model. Because there may be other like co-processors, but not thinking through the trust model carefully. So now that opens an opportunity for somebody. So beyond the marketing, these are the different nuances that actually exist in building an EigenLayer AVS. Some people are building them carefully, and as in any ecosystem, lots are kind of like building whatever they can today and will figure out the better options over time.
So I think that, yeah, it makes a lot of sense. So maybe you can even split up EigenLayer's like demand side into the AVSs themselves, so these services, and then consumers of those AVSs, right? And a really easy example of a like AVS consumer is a rollup. A rollup needs lots of different, infrastructure services. All of them can be specialized. They're not going to operate their own bridges. They're not going to operate their own co-processors, right? And so is the idea here that you can, for the customer, it's kind of like Amazon, where you come into one platform, you get let's say EigenDA is like the core thing you need, right? But then, hey, there's all these other, services, and if they're all here, I might as well, look at them, and they all kind of have the same, uniform security properties, or at least guarantees, right? So I'm not fragmenting my services across different security. And then for the AVSs, especially like these stateless services, it's a distribution play, right? Where they're on the platform, they got eyeballs, and they have the ability to I guess capitalize off of maybe some of Eigen DA's adoption, right? And so, is that the way you're thinking about it? Or are you kind of proactively, I guess, helping put these pieces together when you have, let's say, an Eigen DA customer? Say, okay, here are these other AVSs that you should be looking at.
Yeah, it's a great question. I think the way we went about adoption, our going about adoption is like a spiral. So what's the spiral? So you start, so there's stakers, there's operators, there is AVS developers, and then there is AVS consumers, things like rollups. And the spiral is you look at which is the side that is the lowest friction to start, and that's stakers. Just move money. Okay, that's stakers. Start from stakers, then go to operators, because once you have stakers, they need operators. Operators show up. Once you have stakers and operators, then AVS developers show up. So AVS developers are showing up now. And then once AVS developers are there, then AVS consumers show up. And particularly we being our own like one major AVS developer as EigenDA, lets like AVS consumers show up for that. And then we build tools to make AVS consumers integrate across many AVS developers. So that's the four-sided like spiral, like just go from staker to operator to AVS developers to AVS consumers to then get more stake and like just play the flywheel off that. But we are right now, like one of the things, principles we have is make it possible, then make it easy, then make it scale. Right? Like, so make it possible. Like first, like, is it possible today to be an AVS consumer and consume many AVSs? Yeah, it's possible. Is it easy? No, it's not easy. Is it possible to be an AVS developer? It's possible. And like, chew a little bit of glass to be an AVS developer. And yeah, it's not, is it easy? No, it's not easy. So our principle is first make it possible. We are in the make it possible phase. Once we make it possible, we then make it easy, have more SDKs, ease to build AVSs. The same thing is true with ease to build a consumer of an AVS. Like, is there a roll-up development kit which comes in with like, 20 buttons and say, oh, this Oracle, this DA, this, AI inference, and then like you're a go. That is, one outcome state that we are interested in creating. The other, you asked about network effects, and I think there are a few network effects of like EigenLayer and in general systems of shared cryptoeconomic security, but EigenLayer is specifically designed for this. The number one is the pooling effect. The pooling effect is instead of having 100 pools of $1 billion security for each protocol, if there was $100 billion of security shared among 100 protocols, it's the same fees, but it's more security. It's just better. So there's a kind of like a coordination problem of bringing these 100 things together. That's what we have to solve to be at the center of that, like, pooling network effect. That's the first one. So pooling makes things just like better. The second one is what we call the elastic scaling of security. So elastic scaling of security basically means, imagine I'm a bridge and I can require a transaction, my weekly transaction value fluctuates between 10 million and 200 million. If I were to provision my own security, I have to provision 200 million of security because, I may need up to 200 million. But because I'm drawing from a common pool, there might be a way that, there is this 20 billion and then I draw 200 million this week, but next week I only pay for 10 million because that's all I need. So you can pay for by being, so this is called elastic scaling of security. You're scaling the security to the amount that you need rather than like having your own pool of security. This is the reason why cloud is a thing in our view. Cloud is a thing because it elastically scales compute to how much you need. There's a big pool of compute everybody draws like just in time how much hour compute they want.
Mm.
So there's the elastic scaling of security is a major thing for EigenLayer.
Actually, Sreeram,
Yeah.
just to I want to do a little bit of a callback because one of the things that we're exploring this season that I think EigenLayer intuited correctly, because EigenLayer is not the first iteration of shared security, is Miles and I went back and took a look at Polkadot and some of the earlier shared security iterations in Cosmos. And actually, there's an analogy as well to some other protocols that have subnets like Avalanche, but there's this very consistent trend of creating this like on demand or very elastic demand for compute resources. And I just want to give credit where credit is due. I feel like EigenLayer understands that very intuitively. And I want to underline again for the audience, this is something that earlier iterations of shared security didn't get right. And I think EigenLayer has improved on. So just wanted to make that note
Absolutely.
for the audience.
I think there is still a lot of work that we are doing to get the market structure correct, the pricing and the fees correct for this kind of a model. It's not a easy thing to get right. And like one of the things we saw is, for example, the bundling of security price and computation price is uniform in all of crypto. Everywhere you don't have the nuance of separating I'm paying for more security versus I'm paying for more compute. These two are bundled in some complex mess. So a single Ethereum transaction with transacting $10 billion will cost way lesser than like a big gaming transaction which moves like zero point 0.1 ETH, right? But the first one is drawing a lot of crypto economic load, could lead to more MEV, could lead to reorgs, could lead to like all kind of crazy things, but is not paying its due because you're paying for security should be different from paying for compute, and somehow these two axes were tied together. And you say, oh, a Polkadot auction is giving you like a slot of compute and a slot of security, like it's just bundled in, like there's no nuance in separating the amount of security you have from separating the amount of compute that you want. And EigenLayer's roadmap is to have a pricing function to price these dimensions correctly from first principles, and then like separately price for security and separately price for compute.
Mm. Could we talk a little bit about some of the different, maybe moving on to this next section? I know Miles has a lot of specific questions on this, but just on the different like topology or different arrangements of security that are possible. Like maybe Miles, I know you've got many more specific questions on some of the parameters, but I can turn it over to you here.
Yeah, sure. So I think you've just described like a bunch of different types of security, and maybe like there's even different more clicks to go, I guess, in how these things can look. And so before the show started, we tried to take a crack at like if you were to pick the major, let's say, parameters, or like what are the topology structures of security, and then how can you mix and match them, right, in a way that makes the most sense for your use case. And so before getting into like maybe that side, I'll run through kind of what we were thinking about. So one is just the asset selection. So what are you using as the collateral asset? Is it native staked ETH? Is it a liquid token like an LST or even a stable coin? Is it a special kind of liquid token in Eigen, right? That is meant for specific like types of work. So asset selection. And then I think related to the Eigen piece is what kind of work are these operators doing, and how, is it purely objective faults, right? Very easy to handle. Or is there this intersubjective piece, AKA things that, two humans would be able to very clearly see one is right, one is wrong, but the chain cannot see it itself. And so it's not something that can be completely programmatic, right? And then I think the last one is probably even more, but what happens when there's a slashing event? Is it slashed and burned, or is it, seized and then distributed to the harmed users? And these things, whether it's pooled, or I think that one's specific to isolated, right? But pooled versus isolated is maybe a fourth category. So I'll pause there. Asset selection, fault supported, resolution process, and I think like value at risk models. Is that Is there anything else that we missed there, or would you agree with that
Yeah.
topology?
I think all of this already assume economic security is the right thing. So maybe we
Yeah.
start with whether
Actually, yeah. Let's take a step back.
people
Yeah.
saying economic security is a meme. So maybe we can start
Who
with
are these
a few
people?
memes here.
Who are these people? Sreeram. Who are these people?
Totally is a good example of a person saying economic security is a meme. Recently, Togrul and a few others, both from the Ethereum community, are like, oh, maybe it's true. It's actually correct. So I think maybe revisiting what's the principles on which these systems, the source of trust. Okay, I see really like three different models of trust. The first model of trust is what I would call purely decentralized trust. Like, oh, you have many nodes and they're all different and like therefore they're trustworthy. This model of trust. So firstly, like maybe even zooming out one more level, we see that the whole of the crypto economy is premised on decentralized trust. You remove decentralized trust from it, the whole crypto economy becomes cloud economy. There's no difference. So there's some element of decentralized, verifiable, openness, whatever, you know, different aspect of trust. Otherwise, this whole crypto economy, nothing makes sense. It's just you just go run on a computer. Anything you can run on a blockchain, you can run on a computer. So that's right. Really, fundamentally, that's what it is. Okay. So the first one is like just many nodes, decentralized validators. Like many nodes are coming to consensus, so maybe it's good. The problem with this model just by itself is who are these nodes? How do we know these nodes are any good? And then the usual answer is like, oh, stakers choose these nodes and therefore they're good. But if stakers are choosing these nodes, but they just choose bad nodes for, willfully or otherwise, what is the recourse? Okay. So decentralized trust by itself is, especially in a pseudonymous world, maybe actually much worse than centralized trust because AWS, if it gives you like a wrong answer to JP Morgan's banking calculations, goes and manipulates the server to do it, Bezos going to jail. Like there's a concrete slashing condition that is built into the AWS centralized model, which I think people kind of like, we in the crypto economy try to minimize, but it's real and it's actually the most powerful slashing condition is criminal liability, right? Like centralized models with the reputation and legal liability actually have like a pretty strong skin in the game to get it right. Usually they don't go wrong by making provable errors. They go wrong by exclusion. Like they don't commit errors of inclusion, they commit errors of exclusion. They exclude somebody from building something and just like sneak it under the carpet.
Shout out Low Carb Crusader who figured that out this week.
Yeah, exactly, right? Like, I mean, God knows if we would agree whether Low Carb Crusader did a protocol action like a sandwicher, or did something which is violating the protocol, not clearly defined. Okay, so the first one, pure decentralized trust without accountability, seems like you're getting the worst of the kind of like the real world because you don't have identity and legal liability and you don't have anything else. So that one doesn't seem to work, at least in our view. The other one, which people point out, is, oh, maybe we don't need economic security. It's all social consensus. That's the other view that I've also seen. And this view has, I think, there's something reasonable to it, which is that, oh, if the block was wrong in Ethereum, we will revert the block. And if, there were two blocks, or data was unavailable, like, that block will be forked, all this kind of stuff. It's true, but social consensus operates at a slow time scale, at the time scale of, let's say, weeks to actually get anything done. Because, I publish a header and then I don't publish a block for 3 hours and then I publish a block afterwards. Is this block acceptable or unacceptable? Like there's a lot of things that you have to socially negotiate, just because it's not an on-chain protocol. So social consensus operates at a slow time scale and is only like perceives faults at a slow time scale, not at like, oh, I didn't publish this block within the first like 400 milliseconds and I published a conflicting block. These kinds of things cannot be resolved socially. So social consensus is the ultimate backstop for the blockchain economy, but it doesn't work in the shorter time scale. I don't want to pay for coffee and then wait for social consensus to occur before I drink my coffee. It's not going to work. So what's happening is economic security is the one that is transporting, letting you transport value in the short time scale. And economic security is like adjudicated and like resolved using social consensus at a slow time scale. So this is a correct decomposition of the blockchain stack. Decentralized validation for non-attributable faults. Like, oh, I don't know if I can attribute censorship, so try to get as many distinct nodes as possible. But there are attributable faults like double signing, data non-available, all of these things. And I try to like incur slashing, but slashing will only be incurred in a slower social consensus kind of timescale. So that's the kind of trust model. That's why economic security is needed. So I think, I don't see any alternative to build an on-chain economy without this intermediate scale of economic security sitting in the middle. And what we figured is that people haven't really thought through this carefully. Because if you think through this carefully, immediately it becomes clear that the total amount of value transported within the social horizon should be smaller than the total amount staked. It's a very simple equation once I say it, but you don't see it anywhere else. And like we first wrote it in a paper called Stakeshare, that this is actually what's happening, is that that's what really is being transported by economic security. And we need a mechanism on chain for matching these two numbers. The amount of economic security should be greater than the amount that is value that is transported within the kind of social consensus horizon. And so that's a core principle. So now then we can dive into exactly what is the type of economic security, what is the resolution mechanism, and all of this.
That's a great overview. And before EigenLayer, really the only kinds of security that you could acquire is objective and attributable, which is a pretty limited surface area of, I guess, issues that you can catch, and very limited, and I would say like not actually very good at resolving them, because it's often not the malicious operator whose funds you're actually slashing, right? So now we have, EigenLayer introduces a way to programmatically or a combination of on-chain and off-chain coordination to support intersubjective faults. So this is not needing slow kind of I would say unstructured social consensus to support something like an oracle providing the wrong price feed, right? And the problem with that is, even if you do reach social consensus on the oracle, right, that provided the wrong price feed, you don't have actually recourse to reorg Ethereum, right, where the users were impacted. So now we have a way to actually punish the operators and stakers of something that is intersubjective. And then the last piece that you just touched on is this idea of attributable security, or really insurance. And it won't go like through the whole Stakeshare paper, but it's essentially a subset of a subset of a subset of value is actually at risk at any given time, and it may be small enough and that it's actually feasible that it could be insured, right? Meaning that if it's just, let's say, bridge transactions, or one side of the transactions on chain, the other side is Coinbase paying you USD to settle your withdrawal, right? These are things that today you just end up like Coinbase, right, just waits a long time before it actually lets you settle it. So those are the three types of security now available. And there's a lot of work to do to, I guess, put in place infrastructure that allows, this market to kind of develop for it. But really what I want to get your sense of is, how do you coach AVSs through all of this, right? It's not just you're introducing new concepts. It's, okay, these are all the tools at your disposal. What what do we, how maybe you can't be like totally prescriptive, but if it's just us talking, how would you advise them to think through how to use them? Because it does introduce new complexity, right? And so, but it also
Yeah.
unlocks
So
a lot.
that's a really, really important question. I think the way we think about this is AVS builders are accessing raw decentralized trust. So they need to understand the dimensions of decentralized trust and compose them in ways that make sense. So it is an important and non-trivial job to build an AVS. So AVS building is done with this like of, hey, I need to understand the trust models because I'm providing a service with a certain amount of trust guarantee. Okay, so one kind of generic prescription that works for any fault that's at least transparent off chain is the idea that if I take an amount of insurance greater than the value that I'm transacting within this like social consensus period, then I am safe, right? So it's a very simple kind of a model where you're saying, so the API that, an AVS needs from EigenLayer, how do we simplify this as much as possible? That's the kind of thought that we put into it. And the simplest one is saying, hey, I'm going to transact like $100 million in the next couple of weeks. And like, that's the time for like reorg or social consensus. So I'm going to say that I need $100 million of like worth of this Eigen redistribution or ETH redistribution to match it. This is, I think, a simple enough model for all the faults for which you can actually like slash and redistribute. And I think Miles mentioned briefly, not only ETH staking in EigenLayer has this in the roadmap, even Eigen staking has this in the roadmap where like, when you stake Eigen and if there is a fault that, is attributable from the people outside, then what happens is the portion don't burn all the money of the malicious like stakers. You redistribute portions based on-chain equations, and then like say that, oh, this guy gets this much, this guy gets that much, this AVS gets this much, and so on. So that's the prescription, which I think is relatively general purpose, right? The prescription is what is your value at risk within this like uh, couple of weeks period, and then now you state that value to EigenLayer, make sure you get like that amount of insurance. Now you have the correct amount of cryptoeconomic security. In fact, what you might also want to do is have an on-chain contract for your application. It says, hey, I'm holding this much amount of like attributable insured security. So don't let more than that amount of risk be transacted in the application. This is like a kind of like a formalized circuit breaker. People have like right now, for example, put some kind of a circuit breaker which says, okay, don't want to take too much risk, so I'm going to bound the total amount of bridge volume by X. But this is exactly specifying like a tight counterparty, saying that, oh, the stakers have promised that they'll do this correctly till this much amount of economic value, so I'm actually going to let only that much amount of economic value pass through. So that's a general API that we want to achieve. It's a single variable to communicate like how much trust are you kind of eating from this common pool. And this is not only this regularizes the specific guarantee you get as an AVS, it also regularizes the payment and pricing mechanism. Because you are paying for attribution in a non-leveraged manner, like if I'm telling you I'm giving you $100 million of attribution from the EigenLayer protocol, that means that $100 million is not also attributed to somebody else. So which means that you're incentivized to pay for it, otherwise it won't be there. So that's it regularizes the payment mechanism, it regularizes what you're consuming. And then the question about whether one way to get like attributable security is to have segregated security. You say, oh, you want $100 million of security, just $100 million of stakers are running your application. Right? That would be like a segregated model. And the thing with the segregated model is you lose out on the benefit of pooling. The fact that there's a big pool, you don't benefit from. But the way EigenLayer works is instead of trying to ask each staker to say like how they're allocating across all these different applications, one way you can think of is a staker participates and says that, hey, I'm validating all these different protocols. So if I violate the covenants of any one protocol, I may lose all my money. But how the money is burnt and how the money is redistributed to a AVS, the EigenLayer protocol maintains protocol level calculation to do that. So instead of making these, so the end API is very simple for a staker. A staker opting in is saying, hey, I'm running these 10 things. I have to run all of them correctly, otherwise I may lose my deposit. From from an application, the API is, oh, you have $10 billion of pool security and $100 million of unique security. So that's the so make it simple as possible and do the hard work kind of in the protocol to make sure that the solvency of the protocol is maintained, irrespective of who may draw their attribution at what time.
So these things can all be, like, they can play together, and you can mix and match and choose a combination of, based off of what you're doing. And so maybe let's just make it really clear cut example. Like, how about a bridge that's an AVS, right? So what is a large amount of pooled ETH security get you? Well, that makes the cost of double signing attacks really high, right? And it creates a even larger downside risk to reputations if something goes wrong. What does, I don't know actually if a bridge would have anything intersubjective, but like if it was an Oracle, right? You could pair that with Eigen, right? Which then is also pooled. Let's say there's a large pooled number as well. So that makes the cost of attacking, via intersubjective faults very high. And now within each of those two security tokens, you could measure a second subset of security, right? Or like a smaller, let's say it's whatever, maybe your pooled amount is 1 billion. And maybe let's say on a day-to-day basis, you actually have $10 million of value actually at risk, like meaning these hybrid transactions that flow out of the system that there's no recourse for reorgs. So you would pair that, you would also purchase a much smaller number of I guess, capital that if something went wrong could actually make the users whole, right? So now you have put it all together, you have a much higher cost to attack your protocol in the first place. And if even if there was an irrational actor, right, that decided to attack your protocol, even though like basically what the profit, right, even if it's below the cost.
The reason you need attribution, even if you have a large amount of pooling, is you don't know who else you're pooling with.
Right.
Okay, because when the pool security is attacked, they will attack not one protocol. Just attacking your protocol is not going to be profitable, but attacking 100 other protocols simultaneously is maybe going to be profitable.
Got it.
Very difficult for EigenLayer to know and maintain the crypto economic balance to make sure that the total profit that an attacker can extract from any combination attack will be smaller than the total amount they have liable to lose. This is a hard, non-protocol verifiable calculation. But if you took attributable security for 100 million just for yourself or 10 million in your, use case number, then you would say it doesn't matter who else triggers slashing simultaneously. I will be able to slash and redistribute 10 million to my bridge users no matter what. Like, it's a very high grade of security, which is even if it turns out that the total profit you can extract from attacking all the protocols is much higher than the total amount at stake, you will still get your 10 million back. Like, it is a unconditional correctness for each AVS that they will be able to slash and redistribute their attributable security. So this gives a mechanism for the AVSs to have a guarantee independent of making assumptions about all the other AVSs.
Yep. And why is that actually important longer term for the future of crypto? I don't know if you agree with this, but crypto's inability to reverse transactions is just scary to institutions, to end users, to anybody, right? Worst case scenario, you could have, even if it was like a Swift transaction. You can have government step in to reverse them. That's not possible yet on chain, but you're saying in this future, that's why it's so important to have this actual like redistribution of collateral, and that that will open up, or at least make crypto a lot less scary longer term for like these institutional participants that are not used to be like this new assumption that if they send it to something goes wrong, there's no recourse.
Yeah, totally. And I think like this was one of the things that I got asked is like, hey, who is going to like, nobody seems to care about these kinds of like hard notions of like security and like, pretty much every chain run, like they're all been fine. Like, why do you need any of these kind of fancy primitives? And to me, the answer is typically consumers are not great at doing tail risk calculations.
Yep.
You need the institutions to come in and they'll be like, oh, I'm now deploying at scale. I need to make sure that risk is quantified correctly. And, if you let people decide whether they want to take auto insurance or not, like they're probably not taking like
Right.
car insurance, but because it's kind of mandated at various levels and so on, it just happens. And in the same way, like an exchange operating on like a blockchain would be like, absolutely, I want to take like insurance, attributable security, otherwise I won't operate. And like big players moving their money around would want to take insurance, otherwise they won't operate. Whereas, there should also be space for small players to say, yeah, I'm just doing a small transaction. I don't need to care about all this stuff. Like, just have enough buffer in the system so that they can also operate. So that's kind of like our guiding philosophy that, in fact, this does the right thing, like that, we in the crypto space like, which is let the bigger institutions pay for the premium of being a bigger institution and let the smaller players like operate it a little bit YOLOing into the system and have buffer so that they can operate. And so that is, I think, the right kind of scale. Whereas we
Yep.
don't see that today, that the Coinbase is paying more than a normal user. They're moving a lot of money and they actually pay much, much lesser on a kind of like a, bips basis than like all the other players.
Exactly. Okay, I think that gives a good overview of the so what to why all these pieces should exist. And I guess the last piece on the security side before we move on to, I guess, the segments of use cases that we see for AVS is there. It does beg the question. Okay, we used to have this native staking token as kind of the standard for all sort of either app chains or off chain networks, and whether it's right or wrong, the idea of having a staking token has been beneficial to the market caps of many projects. And so there's a project that's looking at this and saying, okay, well, I knew I wanted restaked ETH, right? I'm not sure about Eigen. We have to do some research there, but what about my own native staking token? And I know that EigenLayer at the moment at least whitelists, the acceptable collateral assets, and so it's not realistic that every single AVS, token is going to be in there. But how would you respond to that, like to
Yeah,
folks that might have concerns?
yeah, totally. I think there are like from the AVS point of view, one of the kind of core principles that we have is open innovation. We want to maximize what innovation happens in the space. And if you take that view, you say, okay, an AVS wants to use their own token in addition or in varying proportion to ETH or Eigen or whatever else, that should be acceptable. So, over time, the collateral types will become permissionless and people will be able to stake their AVS token for sure. Okay, so on the other side, then like, are they leaking value by, also adding and, sending a portion of the fees to ETH or Eigen or something else as opposed to keeping all the value for themselves? And I think there are several factors here. The first one is bootstrapping. Okay, on day one, do you have a token? Maybe you don't even have a token, and you want to build a useful application before you have a token. it's powerful, you want to do it, you can do it on EigenLayer. So that's number one. Number two, I have a token, but it's just starting out. It's a $20 million token, but Chainlink is 10 billion, and I want to provide a useful Oracle service, not capped by my own size. There are because I've figured out how to run this much more efficiently. People are willing to pay for it, or maybe integrate permissionlessly into rollups. Whatever my new feature set is, that's attractive. Security should not be a limitation for supplying the service. And this is one of the main reasons we created EigenLayer, is that security should not be a bottleneck for innovators in supplying services. So that's the second reason for, you say, oh yeah, I get 20 million economic security from my token, but also I get 10 billion from ETH or Eigen or whatever. Okay. The fourth one is the EigenLayer you can think of as pure optionality. Like how much ETH staking to use, how much Eigen staking to use. This is optionality. Over time, you may say that's zero. And that's totally fine. As a innovator, you figured out how to bootstrap your thing. It's enough to stake your token. Just do it. It's totally fine. So because the AVS token is going to govern, it's not, on the governance layer, it is not going to be ETH and Eigen or whatever else deciding how much to allocate security between the AVS and ETH and Eigen and so on. You can say over time, as you figure out, your own economy, you say, no, I don't need EigenLayer, I don't need ETH and Eigen and so on. That's totally fine too. So because EigenLayer is pure optionality, it only increases the value of the AVS token. If you couldn't do this, whatever value that you have, you just have an optionality to turn on and use it, to bootstrap, to insure, to do whatever things you may not be able to do in your system. And there's additional degrees of freedom. That doesn't decrease your value. That just potentially increases. Maybe doesn't increase, but it doesn't decrease your value for sure. So that's the first thing to realize is because of the structure of how we built this, it's incentive compatible for AVSs to say, oh, my token value is not going down because of this. It's, if at all, it is augmented because I'm able to bootstrap myself. So there's another thing that I think people haven't fully understood, which is what is the right collateral for various economic security. And people think of usually volatility as an important metric, and ETH or BTC or USD may have less volatility, but it's not really pure volatility that matters. It is the cross volatility between risk and the economic security device, right? Imagine I'm moving 1 million ETH every week in my bridge. Now my risk is measured in ETH. So if I can get insurance of 1 million ETH, that's just better than getting Eigen or getting in an AVS token, because then I have to measure out for cross volatility risk within a week or a 2-week period, and then buy much more to be sure that I'm covered for my downside risk there. So that reason also gives you another reason for people using the ETH or Eigen. Finally, so then the question comes back to us to say, oh, maybe all that will happen is AVS will bootstrap on EigenLayer and then leave. And the first thing I say to that is, if we bootstrap the whole open innovation economy, we'll be very happy. But the second thing we say is, we have to figure out how to provide value-added services that make it useful for AVSs to stay in the economy, rather than thinking oh, they're stuck with us and we can keep extracting rent from them. And I think this is just not true for anybody. You may think you build an application built on a chain, and if we're extracting too much rent, the application will move out of the chain. So this is just the value-added nature needs to exist for it to be sustainable. So we think a lot about, is it elastic scaling? Is there an economy of scale that when you have many AVSs, each AVS supplies a certain kind of service, and together they're more than the sum of the parts? Is there a switching cost? Is there what set of things that actually make it much more reasonable for AVSs to want to stay over long time scales? And that's a problem for us, EigenLayer, not a problem for the AVSs to solve.
So, Shriram, if I maybe to summarize a little bit what we've talked about so far and move into our sort of final section of questioning here, but we kind of did an overview of state of the union of restaking as it exists today, the amazing amount of progress that EigenLayer has been able to make building out this ecosystem of AVSs, and it sounds like where network effects exist, at least on the demand side of this marketplace that you've built. It sort of has to do with providing value to your AVS ecosystem such that they want to stay there over a long period of time. And obviously there's been an enormous amount of discussion about like what is the right way for these AVSs to procure security and just all the different decisions that they're going to have to think about. I think something that would be interesting to get your take on is what are the different subsections or sectors of AVS, and what's the right way for listeners of this podcast to think about that? And one way that Miles and I have been trying to reason through this, and it's a little bit tricky because it's still so early, but a lot of these words and concepts just aren't out there and don't exist, is a lot of what we've described today in AVS land is what we describe as like external facing AVSs. So maybe the equivalent of, to use a really basic example, like a Cosmos chain that might have existed over in Cosmos land, and now it's using Restake ETH as security, and there's native token yield that's coming to ETH restakers. Another I think large burgeoning use case is actually using restaking more endogenously to ETH, the protocol itself, and using ETH restakers to improve Ethereum, the base protocol. There's a bunch of different sort of middleware services that can be used to do that. So this is sort of what people are excited about with pre-confirmations. You were describing that earlier in the episode. And earlier, Miles and I talked about the intro of this season, like almost an out-of-band solution that could have been described as this MEV boost, which is also getting a lot of traffic today. I saw Donkrad and Peter Solgezi going back and forth about that. But in maybe if EigenLayer was around earlier, that could have actually been facilitated as an AVS. So I think people are really excited about this idea of almost like endogenous, using some of the allowing proposers to commit to these additional things and actually improving parts of Ethereum, the protocol itself. And I think that gets lost in some of the discussion of, oh, we're going to secure all these protocols and bring all this yield to Ethereum stakers. But I think one of the really exciting things that doesn't get talked about enough is the potential of restaking to allow us to accelerate the growth of Ethereum and to enable really cool things like base sequencing and solve the fragmentation problem on the rollup layer. You could accelerate the adoption of single slot finality, things that would, if we were to do this through an EIP, would take many, many years, but now we can almost iterate on them in a restaked way. And then maybe if they're successful enough, they could find their way into the protocol. Are we thinking about that the right way? And like, how would you define that whole category?
Yeah, absolutely. I think the reason we haven't, I gave a talk on like MEV Boost plus plus in the Stanford Blockchain Conference in 2022, September. So we've talked a little bit about this before. The reason we kind of like stopped talking about it over the last year or so is this problem that when $1 billion is a lot of economic security for pretty much any application, but $1 billion is not enough, is only like 1% of the block proposals on Ethereum. So this, like, Ethereum's such a big like ocean liner that to barely make a dent on it, now we are starting to be at a scale where we can say, okay, proposer commitments may start to make sense because 10% of block proposals, something like that. So that's a very important like thing, that Ethereum's such a big thing that like getting enough block proposers to actually participate in restaking, so then you can start doing these kinds of services. We're just starting to be at scale to do it. So one of the reasons we haven't focused a lot on this in the past, and we're going to start to focus a lot in the coming years, right? Like we're a very Ethereum native project, and improving Ethereum is very important, and a huge part of why we're doing this. And so we'll start to see like many things happen in this proposer commitment landscape. But to give a sense of what kinds of things can you do, right? Because you have this ability. The first thing is you can start doing, pre-confirmations, right? Like I have a rollup and I want the rollup to give a confirmation to users. The rollup is using Ethereum itself for doing transaction ordering. But if it's using Ethereum for transaction ordering, you have this big loss, which is that you have this like really amazing like instant confirmation in Arbitrum and so on, where you're used to, hey, I got confirmed in like zero time, and now I have to wait for Ethereum block. It takes 12 seconds, and like you need to be sure that that block is in. All of that. It's just a like spoils the UX completely. Instead, if the block proposer was restaked and they already can make an extrinsic promise that, hey, I am going to include your transaction later, that can happen in 300, 400, 500 milliseconds. And then when they include it, they include it. And if they don't include it, they'll get slashed. So restaking actually gives us this ability to add features and change the time scale of the Ethereum protocol in a way that like you couldn't do before. And it allows us to do it because, like I mentioned before, because EigenLayer has native restaking built in, allows for universal participation in that kind of an economy. It doesn't. I don't need to be like in an LST or something, because that's one thing that is inevitable is without an optionality like this, like major exchanges or major node operators can make off-chain promises about various things, and they'll be credible because they're big and huge and they have the ability to make those kinds of promises. But smaller operators and like permissionless global operation is not going to be possible with that. You need trust and reputation and aggregation and centralization to actually make those kinds of promises. Just like MEV Boost was a kind of an attempt to make it transparent and democratic and permissionless for anybody to participate in that, native restaking allows anybody to participate in, let's say, pre-confirmations. What else can we do? We can start doing things like partial block auctions. I can promise I'm selling a portion of the block to Mike and a portion of block to Miles, and this claim will be credible because if I don't do it, I'll get slashed. You can start doing block space futures by saying that whenever I get block, participation in the future, I need to include ABCD. If I don't do it, I'll get slashed. I can start doing event-driven actions that whenever a liquidation shows up, I have to include the liquidation in my block. If I don't include it, I'll get slashed. So we think the space of pre-confirmations is pretty huge. It's like we're barely getting started with this. It's one of the places where we find that both big players can participate really well in a market like this, and small players can participate because of the native restaking and stuff. The big players can participate because they have a little bit of an economy of scale. So imagine I'm a big player. I have like 5% of or 10% of like, slots in Ethereum. Now, I don't need to restake the 10% of all my proposers to participate in this market. I might just put enough value at risk, say put like, I put 10,000 ETH. So that's a big enough number, and say that whenever I do this, whenever I get these slots, I will do my actions correctly. And you're making a promise for a huge amount of like ETH or slots, but you've put up like, this 10,000 ETH, and because slashing and like redistribution can happen at a faster time scale, then I'm going to deplete that 10,000 ETH. It's good enough. So big players have like this, I don't need to restake everything, but I can still participate in it. Small players have an advantage that I can just natively restake and participate in it. So everybody can kind of participate in this proposer commitment economy once we have like rich expressive standards. So that's the direction that we want to take going forward, where like all these different players can come together and participate in a universal like proposer commitment economy.
I'm honestly, I think I might be maybe more excited about this category than even the native or the external restaking. I don't know, it's pretty even, but this is what I'm really happy we're talking about it, because I think earlier this week we saw Lido. They announced that they want to support pre-comps. And I guess if you think about the characteristics of this category, I guess its usefulness, to your point, is a function of participation, right? So these things don't even really become possible until you have, a good portion of the, or not possible, but useful until you have a good large portion of the set that's opted in, right? And then two, these are only things that interact directly with Ethereum consensus, and these are basically plugging into the whole EVM value chain. I guess the last piece that I'm a little bit unsure on in terms of the difference between external and native is external restaking. It's typically the operators that are actually running new services, right? They're running software, hardware to actually operate these services. Whereas today's MEV value pipeline or workflow, right? We have this idea of proposer builder separation. And so that's just one example of proposer worker separation. Do you see all of these different pre-commits, or let's say just proposer commitments broadly, whether it has to do with MEV or giving an L2 a pre-conf, right? Do you expect to see the same sort of separation, or is it actually going to be the proposers are running a bunch of software here too?
Great question. We've thought a lot about this for many years now, and one thing we started seeing is people started talking a lot about things like builder commitments. Oh, a builder can give you like commitments that they will do like this and that. I think this is a very bad trend if we get a lot of builder commitments. The reason is builder is not an Ethereum protocol role. And Ethereum has done a lot of work in trying to keep block proposers decentralized. So now, like, if you say builders are making commitments, firstly, it centralizes the builders. Maybe you say it's okay. But the problem is builders don't have like monopoly power even temporarily in the protocol. They have like very weak kind of competitive monopoly powers, not like enshrined monopoly powers. Proposer is the one that actually has protocol level monopoly power. That slot belongs to that proposer, right? Like and it's the role that Ethereum and Flashbots and MEV management has worked hard to keep decentralized. Okay, so given all this, how does proposer commitments fit in? There's a bad world where we say, oh, you should not do builder commitments, we'll just do proposer commitments. And proposers are now burdened with running like very complex additional software. Okay, so that doesn't make sense. Builder commitments doesn't make sense. So what makes sense is our theory is proposers make commitments that builders keep and relays verify. Proposers make commitments that builders keep and relays verify. Proposer is the one that's in the protocol. They better like have a say in what, it's not a censorship commitment that they're making. It's a inclusion commitment over liquidation. It is because, there is dystopias abound in this kind of proposer commitments. And we want the wisdom of the crowd in adjudicating what is the right things to do, which actually like bring right value to the Ethereum protocol. So because you could very easily build a censorship market on top of, proposer or builder commitments. You take the three top builders, pay them money and say, don't include Mike's transactions. And, you'll get liquidated and then I'll take
Rude. Sreeram, I've got a question for you on that. And we did an episode on pre-confirmations actually with Hart last season. We had Primev and Chainbound on, and they were actually, it's interesting. The market might be taking care of some of this dystopia because Primev's original angle was starting with builder commitments, and they're one of the prerequisites of getting builders on this, getting them on board was that you actually needed the buy-in from the proposer because they didn't actually have the monopoly power over the block. And so I think actually there's a little bit of market conditions, this is one of those nice situations where the market conditions are kind of giving us the beneficial outcome here, which is extremely nice. But I know, Miles, you got a question on just like the relative market size here, but could you just walk listeners through, Sreeram, that exact instance? So let's just go through what is an example of like a commitment that a proposer makes, that a builder executes, that a relay verifies. Just walk us through that, like one example.
Yeah. Let's say I have a protocol, a liquidation protocol that says that, it says here is a pool of liquidators, and whenever this price is below this, according to this on-chain verifiable state, trigger a liquidation. right now, like, when you look at, for example, when and how a decentralized stablecoin is viable, one of the problems is the over collateralization requirements of the how much you need to deposit relative to, like, what you're backing. And the over collateralization ratio is dependent on the time to liquidation. Because if you can liquidate every block, is a different over collateralization ratio from if you can liquidate in, like, 50 or 100 blocks. So it reduces the over collateralization linearly, like the additional factor goes down linearly. It's a really crazy powerful thing. Okay, so if you look at the so processing liquidations consistently and within a block or a couple of blocks is a huge advantage to these protocols, because they can now enshrine powerful parameters rather than requiring like some external assumptions. So what this does is, okay, so now a proposer commitment is whenever this protocol is under, I would do trigger ABCD transaction. This is a proposer commitment that, let's say, 80% of proposers made. So, like pretty much every block, somebody has to come and do it. But who's doing it? To trigger this, I have to check all the protocols that we've opted into, check whether any of them are underwater, and then include those transactions as a kind of forced inclusion in this block. That's what the proposal has to do. But that's a lot of work. Like, I have to have additional software running. I need to have awareness of, Compound and Aave and Maker and everything, and like just headache. So that's a commitment. Now a proposer says, oh, liquidation for Aave, Maker, good things. I'm getting like some Aave tokens, Maker tokens, or like some like regular drip of fees, something. I opt in. And like that's what the proposer is doing. Then the builder comes in, and the builder, there's a signaling language that is already agreed on, and the builder comes in and says, oh, that's what the proposer has agreed to, which means this block will be invalid if I don't include those liquidation transactions. So now I'm constructing the block. I already take into account the constraints of the block, in my MEV, like auction, whatever other thing I'm doing. So this is the constraints of the block. This is like pre-conf transactions. These transactions have to be included. I included. Now auction the remaining block, construct the block in whatever other way, but this has to be included. And I do this, and then I construct the block, send it to the relay. Relay knows the grammar. Relay knows that like these liquidations have to be processed, checks it, signs it off, and then sends it. There's a lot of questions about exactly what this grammar is, what is the language, does it work with an optimistic relay in the MEV pipeline, all of that. Like, so we have to sit down and spend years decoding all of this stuff, which is the kind of fun we like to have. But that's what the kind of generic structure that we are envisioning.
Okay, that is really, really helpful. And I think there's kind of two questions off of that. Who puts up the capital at risk if they do not uphold their commitment? In this case, is that something that a proposer could actually outsource potentially, or is that something that would come from the proposer, and maybe there's some sort of like recourse to the builder another way? I'm not actually sure.
Okay, great question. So number one, you could say proposer is restaked, right? So they are restaked, so which means like they are putting at least their collateral at risk. But in a scenario like this, the total amount of economic security you have is bounded by 32 ETH. Like now, you can say, oh, every proposer will do it, but I'll say, oh, let me eat the loss and take 32 ETH and like now not process the liquidation, take a bribe greater than that, whatever. So it's possible. So how do we go to more rigid kind of commitments? Like this is the next step. And then you can think of actually, oh, maybe a proposer doesn't sign off on a block by itself, but a proposer's key is split into like a DVT type scenario, and there is a committee of like 50 people who have staked much, much more. And they actually have to sign off on this transaction. And if they sign off on a wrong transaction, they're going to get slashed, not 32 ETH, but now 1 million ETH. So it's like internalize an economic committee into your proposal process, like create another level of much higher economic security without interfering with the consensus. we have all the pieces kind of in the space floating around. We have DVT floating around. We have economic
Yeah.
security with EigenLayer floating around. It's going to be a whole bunch of fun work to make this all work, but it's possible to make it work at much higher economic fidelity than 32 ETH, because that is needed to build $1 billion decentralized stable or $100 billion decentralized stable.
Yeah, go ahead, Mike.
No, I was just gonna say this is super. You
Yeah.
just answered. I'll talk about this in the debrief, but you just answered a massive question for me that I've always had, which is how are these proposers going to actually enforce these commit? Like, I'm thinking about the solo stakers, right, which are already like sub 10% of the network. And whenever two people brought about like Pepsi or pre-comps, I was just like, how are these people going to do this? So you just unlocked that was a massive unlock for me. And I also think it's interesting that Ethereum is going this direction, maintaining the monopoly of the proposer on the block, where it seems like Solana is going in this direction of async execution and breaking that monopoly up. Not a question, just an observation that like very diverging paths, and I'm super curious to see how both of those.
That is a great point. One of the ways that we think Ethereum, at least our Ethereum ecosystem, inherits some of those properties is EigenDA, for example, is a no proposer monopoly system. So what you do is, if you want to disperse data to EigenDA, anybody who has data just sends it to the end node, then they can get a receipt. It's a completely asynchronous, lock-free system operating at the absolute max throughput possible. So everybody can send it parallelly, and then like you get all these receipts, and then these receipts are serialized when they are returned on Ethereum. So you have the Ethereum, which is this underlying system which can maintain this locked system where like one proposer monopoly actually like arranges all these receipts, but you also can have like outside systems. This fractal-like nature of Ethereum is going to be like so interesting to watch how it pans out, because having a very rigid, strong base and then letting like the market kind of innovate on everything else, like what we're trying to do with EigenDA, is actually like a super interesting view there.
Yeah, it's like, can you get the benefits of, it kind of reminds me of like the block size wars. Can you get the benefits of bigger blocks without, while retaining a lot of those same properties, the properties that you want, right? And I guess my last question on this is, I find it super interesting to think about, just to contrast this kind of restaking to what all AVSs are today, really like external restaking. And I think, from a value like flow standpoint, it's potentially like a more unconstrained market size, because it's more like similar to MEV Boost. A lot of these commitments are going to be forms of revenue share to the proposer, rather than with external restaking. Right? It's a cost for the AVS that is now newfound revenue for the supply side. So the cumulative market size of external restaking is always going to be constrained to what the total willingness to spend is for security, versus this category you could argue is like it's much more unconstrained, because it's just how much is available actually to profit, or to in some ways benefit from the ability to pay proposers to make like these additional commitments. It may
it's
even
it's an interesting question. I don't think it's that simple. The reason I don't think it's that simple is that the net willingness to pay on exogenous services is the net exogenous economy, which is still getting verified on Ethereum.
Yep.
And so the question is, how much of economy stays on like, or is fundamentally under the writ of the Ethereum L1, versus how much of the economy is much more free floating and under the writ of the L2 economy.
Right.
Imagine like an L2 sequencer can offer L2 MEV services on EigenLayer without having any of these other constraints. So it's basically that question, rather than the question of like, cost versus benefit. I guess like that also there's some benefit, but except though that there is no like monopoly power to extract that benefit. Whereas on Ethereum L1, there is a monopoly power to extract that benefit.
Right.
So maybe that's what you're alluding to there, in the sense of, hey, we have this system which is already transporting enormous amounts of value. Like, what kind of things can we build on top of it? But our view is that we want to move cloud to crypto. Like
Yeah.
it's just
Right.
where we start. And so that means like I can't move all of that to Ethereum L1. So we need all these other things. And over time, these other things are going to be like a massive economy. That's the bet.
Yep, I agree. So maybe that's more of an observation rooted in like this point in time, right? Versus where we know the space is going. I've always thought of EigenLayer as a way to horizontally scale Ethereum, where rollups is kind of the answer to vertical scaling. Is that maybe just kind of like a not precise, but is that a fair way to look at it?
It's a good call out. I think the model that I have is, I wrote a tweet on this once, which is Ethereum is the verifiable internet. Rollups are verifiable web servers. AVS is verifiable SaaS, and EigenLayer is the verifiable cloud. So the idea is basically like just like the internet allowed anybody to put a web server and they can kind of talk to each other through the internet. But when they talk to each other on a web server, the other server doesn't know that the original server did what it's supposed to be doing, right? And Ethereum is this verifiable internet. So I plug my web server in and like I can prove to you that I did the right thing. So that's a rollup. A rollup is basically like a web server that's kind of plugging into this like verifiable internet. And so is there an advantage of having verifiable internet? Yeah, absolutely, because I know when you're telling me something that you're telling me the right thing. And that's a big deal. And the obvious place where it matters is money, right? Like you tell me how much balance I have and I know that's the balance I have rather than hoping that you're telling me the right thing. But so this is the model. Rollups are verifiable web servers. And then like when you think about web servers, like web server used to do like pretty much all the application logic was sitting on the application web server. Then over time you find, yeah, but identity is a universal service. It doesn't have really much to do to the Amazon book service. It's a universal service. It's the payments is a universal service. Like maintaining a database is a universal service. And going from each application maintains its own entire application logic to abstract out portions of things which are common, like bridges is common, Oracle is common, a database is common, like this is common, AI inference is common. Create these as like SaaS services. That's what happened in the internet is you have these software as a service layers that actually then service those things. In the EigenLayer worldview, we think of AVSs as abstractions of things that worked well in a particular rollup or a chain context and then abstract them as a service. As an example, let's say Osmosis has threshold encrypted mempools in its roadmap, and it's such a useful productive service. But really, if you ask, is it specific to Osmosis or it's just a useful service for a lot of people? Just a useful service for a lot of people. And the market structure of an app chain kind of ties the things together in a very tight manner. Extricate that as a service, run it as an EigenLayer AVS, you have an encrypted mempool that anybody can now subscribe to. So AVSs are verifiable SaaS. So you have an encrypted mempool, but you know the encrypted mempool is supposed to be doing what it's supposed to be doing. And now all of this runs on like EigenLayer decentralized trust and staking and so on. And so that's the kind of view, and it's a completely complementary view to the roll-up era. Like it's actually like supporting the roll-up era a lot more than it is kind of conflicting with it. And it's turbocharging it because, for example, a roll-up had to be verifiable, had to write data at Ethereum, doesn't scale. Create a service, EigenDA, it scales. Now you throw all the data on that, and now you can interoperate among all these other things. So you can just like abstract out each of the services that are needed to make this Ethereum the universal verifiable internet and just like funnel more and more into it. So that's our kind of view. So it is true in that sense that rollups are basically like these web servers are parallelized and like individual nodes running, whereas there's a group of horizontal services that are across all these web servers that help do things that are common to all of these things.
Sure. I love that. That was a great, helpful for me for actually just like a mental model to think about how to view the AVS versus rollup. I know we've kept you for a long time. I want to end on this question here. Like we've already gone so long. The the subtext or some of the back stuff that's going on in the background of this entire conversation and the success of restaking is a debate around issuance on Ethereum. And this has primarily been focused within the liquid staking ecosystem. There's a phenomenal podcast, I've referenced it many times already, on Uncommon Core, John and Hasu and Casper and Ansgar, where they outline basically there is a proposal in the works, or early stage proposal, maybe it's going to happen, maybe it's not, to tinker with Ethereum's issuance. And the way that the issuance works right now is that there's kind of a curve that looks like this, where the fewer stakers there are, the higher the rewards, like the more issuance goes. But as we get more and more stakers on the network, the rewards tail off after a period of time. And there's a proposal out there to actually target a certain percentage of stake, wherein the rewards would trail off to such a degree that they would go to zero or actually negative, to basically target a certain percentage of stake for the network. And there are a couple of different reasons for this, a rationale in different camps. And one of the rationales is that, hey, you could really view stakers as a external service providers to the network. Maybe the amount of security that Ethereum, the protocol, needs, right, is maybe we think it's just as safe as 25% as it is at 60%. So if we have 60%, we're overpaying, right? And we should redirect that elsewhere, namely to the holders of ETH, the asset. The other thing is, if you can have something like Steth, which is even just as liquid as Ethereum itself, and it bears yield, then there's like a preference that many people will want to hold Steth instead of ETH. It gets yield, it kind of earns some of the moneyness, and maybe we're preferencing the LST and forcing users into taking these trade-offs, security trade-offs that they don't really understand, instead of ETH the asset, right? Now, one of the other interesting points around this is, what does this do to the validator set of Ethereum, right? Because if you set a certain target, then the argument goes that you're actually only allowing the largest, most economies of scale, profitable validators to operate, which would basically be Lido and Coinbase. So there's an argument that I think Hasu has made convincingly, that you actually are limiting the amount of solos. You're making it much tougher for solo stakers. And I would just be curious, I haven't you really comment on where you see restaking belonging in this issuance debate. So I'd love to get your perspective on that. I would also love to get your perspective on how you see restaking impacting the validator set of Ethereum. That was a lot, but pause there.
Okay, there's a lot of prolific and well thought out people who have spoken on this. So we've kind of kept our mouth shut for the most part.
Sometimes that's
But but here is a kind of I don't want to wear my EigenLayer hat to answer this. I'll wear my professor or researcher hat to answer this question. I think the starting point of the problem is, how much security is enough, and what are we paying for? What are we paying for? What are we getting for it? This is number one. Is 25% enough? Is 50% enough? What is this thing? It's a fundamental problem that is unclear in the current setting. It's all human-made curves, and we're going to fight about all human-made curves day and night. Number one. Number two, Ethereum as a protocol has needs that it does not know how to enforce. Okay. Controversial, but I'll say it. Ethereum as a protocol has needs. It wants censorship resistance. And to get censorship resistance, we need, right now, the only way you get censorship resistance in Ethereum is that you need a decentralized validator set. And Ethereum doesn't know what a decentralized validator set is, how to incentivize it, how to give more rewards to it. So it wants a property, it wants to guarantee a property that it doesn't know as a protocol how to guarantee. I narrow down the whole debate to these two problems, fundamental problems. Number one, how much security is needed? Number two, you want properties that you have no way to enforce as a protocol. So my instinct is, let's go solve these two problems. Not saying whether chaining issuance good or bad in the short term. It's up to the Ethereum folks. There are plenty of brilliant people to think about it. But my questions are just these two. What do we need to do to make the amount of security a market-driven variable, rather than a protocol researcher drawing a curve? Number one. Number two, what do we need to do to make sure censorship resistance is not a property that we get out of social badgering? Instead, censorship resistance is a property that the protocol knows how to get directly. That's the two questions that I'm most interested in. I have return an answer for the first one. That's called stake sure, which is try to solicit the amount of security that you want in protocol and then send it to it. But by itself, it's not sufficient. The reason is, even if you applied stake sure, and let's say the answer is we need $10 billion of stake security in Ethereum, that $10 billion will either be Coinbase or Lido. That's what it will be. And like, we'll be unhappy at that because, these guys are whatever. I think it's just like bad principle for how that is done, because it's coming down to the second problem, which is how do we enforce censorship resistance without resorting to social badgering? Okay. The answer to the second one, at least the starting point, is I gave a talk at the censorship.wtf workshop called Revere. Revere, from the American hero who kind of like drove on a horse to intimate of the coming British troops. And it's kind of like, hey, censorship is happening. How do we intimate? How do we make it observable to people that censorship is actually happening? And so we need a lot more mechanisms, but it's a starting point. But my dream Ethereum would solve these two problems at the foundational level and get rid of these issuance discussions once and for all. Because you're kind of like trying to socially engineer some properties that you can't engineer in the protocol level. And I just don't like it. I don't like it. And we have to negotiate with Lido and Coinbase and me, and like I don't want to negotiate with the protocol. It's a protocol. Just tell me what the protocol is.
Yeah, I completely agree with it. It's funny. It's just like regular monetary policy. It's often like a proxy action, and it's kind of like taking a hacksaw instead of a scalpel, or chainsaw to a butter knife, that type of thing. Whatever, pick your analogy. But and then I guess like final question there. I know we're really over time here, but just do you see restaking impacting the Ethereum validator set as well? Is this actually a tool for solo stakers so that they can earn more and it's more attractive to be solo at-home stakers? Do you see it putting some kind of impetus on solo stakers overall? Does this favor large stakers versus small? Like how, if at all, do you see the adoption of restaking impacting the Ethereum validator set?
It is TBD. And I think the way to kind of think about it is, what have we done to like minimize impact on the validator set? So the first one is we built EigenDA when we built restaking. It's not at all accidental. There are many, many reasons. One of the reasons is, if you build a system of shared security where everybody has to run everything, and the only way you can scale is by everybody running everything, then that system has massive centralization pressure. So any other restaking protocol which is not built with like a scalable DA at its base layer has this big problem, which is that you're putting a lot of pressure for everybody to run everything. And if everybody runs everything, then you're putting centralization pressures. So that's number one. So trying to make sure that there's at least like a horizontally scaling substrate on top of which you can throw more data, everything. I don't need to have everybody download everything. So that's number one. Number two, preference expressivity for AVSs to specify whether they want more decentralized versus more centralized validator sets. If I only care about how much ETH is staked, then do I really care if it comes from a home staker or not? Maybe not. But if I care about like slot shares, then I want, of course, like anybody who has a slot to participate. But separately, if I care about sending secrets to various nodes, and together they're storing a secret, I better find a pretty decentralized validator set. So there are different use cases. Some use cases are going to be very happy with like a lot of ETH. Some use cases are going to be like, just give me the same as Ethereum. And other use cases are going to be like, I want even more decentralized than Ethereum because I don't want 30 nodes to control it. I want 3,000 nodes to control it. All these three are going to exist. What is the relative revenue share, users' preferences? We don't know. The other thing that we did with native restaking is to give the ability for you to be a home staker for Ethereum, but to delegate for restaking. It's an optionality, right? Like I'm a home staker for Ethereum, but EigenDA, I don't care, just like Coinbase run it. It's okay. So that's the sets of things we've done, trying to make the protocol as like positive sum to Ethereum as possible.
Awesome. Sreeram, you have been extremely generous with your time. Miles and I still had a bunch of questions we didn't even get to, which is crazy even at the end of this. But yeah, man, we just really appreciate you coming on, and it's always just a treat to be able to get to talk. Obviously, at this point, folks will be very familiar that you are the founder and CEO at EigenLayer. But if folks want to find out more about the work that you're doing, or if you're listening to this and you're interested in becoming an AVS or somehow getting involved with the EigenLayer ecosystem, what's the best way for people to do that?
Yeah, reach out to DM me at Sreeram Kannan is my Twitter handle. I'll connect you to the right people in the team to work on AVSs. There's also a research forum, research.eigenlayer.xyz, where if you have ideas, problems, or hey, this is a thing I don't know how EigenLayer is solving, or here's a proposal for how to solve it, or here's something that can work well with EigenLayer. Super happy to engage in those discussions. Please post that.
Awesome. Well, Sreeram, this was a blast, man. Thank you so much for coming on. We will have to do it again sometime soon.
Thank you so much. Thanks, Mike. Thanks, Miles. Really, really enjoyed this chat. One of the absolute best.
Yeah, that was awesome. Thank you.